Okay, so classification is a pretty straightforward topic. If you get a question on this, you should be pretty happy. But it also links in with some of the organic reactions. So while there may not be questions directly asking you for the classification of compounds, it's sort of a foundation understanding that you'll have to apply to some of the different organic reactions. So the idea is that depending on what a given functional group is attached to, well, it'll be attached to a carbon, but depending on what else is bonded to that carbon, it changes the behavior of that type of molecule. Okay, so what am I talking about here? We're going to be classifying carbon atoms or types of molecules as primary, secondary, or tertiary, and in a very limited case as quaternary. So the idea is that a primary carbon atom is a carbon that's only attached to one other carbon atom. A secondary carbon atom is one that is attached to two other carbon atoms, and a tertiary carbon atom is attached to three other carbon atoms. So looking at the examples below will help us understand that definition. So this first molecule at the top left that I'm looking at, this is a halogenoalkane. I can see bromine is attached to butane. The bromine is attached to a carbon atom that is only attached to one other carbon atom. Otherwise, it's attached to hydrogens. So this halogenoalkane is a primary halogenoalkane. It satisfies that first definition that this halogen, which is our functional group, is attached to a carbon atom that's only attached to one other carbon atom. So that's where the one and primary comes together, only attached to one other carbon. And that's relevant because in this example, the bromine is really sticking out at the end of the chain, and this carbon has one carbon-to-carbon bond and two carbon-to-hydrogen bonds. So it changes how this molecule can react because it has different bonds attached to it, so it becomes more or less likely to undergo different chemical changes than a carbon that, in the next example, this carbon is attached to the bromine, so that's the carbon we're focused on. It would be described as a secondary carbon atom because it's attached to two other carbons, so it's got two carbon-to-carbon bonds and only one carbon-to-hydrogen bond. So that changes its chemical behavior, and it changes what it might be able to be converted into in a chemical reaction. So this would be a primary halogenoalkane, and based on this carbon, we'd say this is a secondary halogenoalkane. Of the last two, the one on the bottom right here is a tertiary halogenoalkane, and that's based on this carbon that's attached to the bromine. This carbon is attached to 1, 2, 3 other carbon atoms. So it actually has no hydrogen attached to it, and that will definitely influence what types of chemical changes it can undergo. So primary, secondary, and tertiary examples. The one on the bottom left is perhaps the trickiest to figure out, or the most likely to sort of trap people. So this carbon in the center is a tertiary carbon atom because it's attached to three other carbon atoms. But if we're being asked to describe what kind of halogenoalkane is it, what is the classification of the halogenoalkane, then what we're being asked about is not that central carbon. We're being asked about the carbon attached to the halogen. And that carbon, so the one that really is important for this question, is attached to only one other carbon. So the one on the bottom left is a primary halogenoalkane. So you can have a tertiary carbon atom in this molecule, but if they ask you to describe the classification of the halogenoalkane, then you need to look at specifically the carbon that they're talking about that's connected to the halogen. This exact same system is used to describe alcohols, whether or not they are primary, secondary, or tertiary. And you can sort of see it in the condensed structural formulas. It does help to draw them out. But knowing a bit about organic structures, if you see a CH2, that tells you that that's like in the middle of a chain. And so if the OH is sticking off at the end, then I can already see, without drawing the whole molecule, that this one is primary. It's a primary alcohol because that carbon that's attached to our functional group is attached to one other carbon. I can see here that this carbon has an H off of it and an OH off of it, and then it has CH3 on either side, so it's going to be secondary. This one is a very, I can tell it's very branched. I know that CH3s are methyl groups, and they are the ends of chains, and there's 3 of them. So pretty good guess this will be tertiary. The carbon has an OH off of it, as well as 3 methyl groups, which I can leave nice and condensed, and I can still see that this one's going to be tertiary. And finally, this one, if I draw this out, I get CH3, C, CH3 off to the side. That's what the parentheses tell me. Then I have the OH, I get the CH2, CH3. And so now when I draw this one out, I can see this is also tertiary. Because again, this is the carbon that matters. It's bonded to 3 other carbon atoms. So tertiary alcohol. The last type of group that you could be asked to classify doesn't come up too often in the core syllabus. It's normally an option question, but it could come up in the core syllabus. You can also classify amines. Now, an amine group is the functional group that's closely connected with ammonia. So it's these groups that have N and H, and then they're single bonded to carbons. And generically, we'll see R used in organic chemistry to represent carbon chain of some length. So that's why they've used R here. So the only difference in classifying amines is that you're looking at how many carbon atoms are bonded directly to the nitrogen. As opposed to these other ones, you had the hydroxyl group making this an alcohol, but it's not how many carbons are attached to the hydroxyl group, because that's always 1. It's how many carbon atoms are attached to this carbon atom that's attached to the hydroxyl group. So this classification concept still always comes down to how many carbon atoms are there off of the relevant atom. And so in these groups up here, we were looking at how many carbons are off of the carbon attached to our functional group. Down here, we're looking at how many carbons are off of the nitrogen. So if there's 1 carbon off of the nitrogen, it's called a primary amine. If there are 2 carbons and only 1 H off the nitrogen, it's called a secondary amine. If all 3 bonds coming out of the nitrogen go to carbon, it's a tertiary amine, and it's actually possible to have 4 carbons coming out of it if it's positive, and that can be called a quaternary amine. Okay, and it's actually, I show this example. This is a picture of adenine, structure of adenine, which is one of the nitrogenous bases in DNA. And you can look at, it's full of amines. And when you look at this one, if you fill in the corners with carbon atoms, you only see 2 carbon atoms. However, there's a double bond to one of them. So there are 3 bonds to carbon, and therefore this nitrogen is actually tertiary. So it's not just the number of atoms of carbon, it's the number of bonds to carbon. So these 2 are both tertiary, and actually this one over here is also tertiary, whereas these 2, well, actually this one is secondary. That N is attached to an H, but also to a carbon here and to a carbon there with single bonds. So 2 carbons, single bonded, secondary. And this N just has a single bond to 1 carbon, and it has 2 H's. So this amine up here is primary. So classifying different types of molecules is a question they could ask you outright. And for the halogenoalkanes and the alcohols, it's going to be relevant for some of the reactions that we're going to learn in the organic chemistry topic.